All right, good afternoon, everybody. Welcome back to Pre-Calculus. We are going to be talking about conic sections. Specifically, we're talking about ellipses today. So, unfortunately, this is one of those times when Alex gave us the least bad option as far as choosing a textbook. So, most of these problems are going to go through A through H, A through Q, A through T, kind of a thing. So they're all multi-part type of things, and there's a lot of things that they ask. Some of them are the same thing over and over and over again, so that's not too bad. But it can get a little bit tedious. So please try to schedule some extra time to do these problems because they do take a while. Okay. So let's see here. Mostly what we're going to be looking at first here is where is the center of an ellipse? You know, you're in the 10.1 section, 10.1 here, so you're going to know that we're going to be talking about ellipses for this whole thing. Okay, so let's pretend we didn't know that. If we ended up having an equation here, we have x squared over 49 plus y squared over 64, so we have x squared over 49 plus y squared over 64 equals 1. What's the major axis? Well, how do you know it's an ellipse? Both of them are squared, okay? And there's a plus between them. So if you remember what, circles look like, x squared plus y squared equals r squared. This would just be x squared over r squared plus y squared over r squared equals 1. If r is the same, then it's a circle. If they're not the same, then it's an ellipse, and it's an elongated circle or a squished circle, either way. So the major axis is the longer one. So we're going to use something called the method of intercepts for a lot of problems in this section. So we're going to set x equal to 0. We have y squared over 64 equals 1. Y squared equals 64. Y is equal to plus or minus 8. Okay, so our radius in one dimension is going to be 8. Set y equal to 0. Okay, so we're going to have x squared over 49 equals 1. X squared equals 49. X equals plus or minus 7. 8 is a bigger number than 7. So our major axis is along the y direction. Our minor axis is along the x direction. So this would be the minor axis. This would be the major axis. Okay. So that's what we're going to do. And this is where your book turns into a little bit of a problem because they get really specific on which one's A and which one's B. I think the major axis is always A and the minor axis is always B. That's the way I would have done it, but I wouldn't have made such a big deal about it. I wouldn't have phrased the question in terms of A's and B's. I would have termed it as like major axis and minor axis, rather than making you memorize like which letter goes to which thing, because that really doesn't matter so much. Okay, so the center is, we don't have an adjustment. Okay, remember when we talked about circles that we had like an x minus h squared plus y minus k squared. You probably learned that in Algebra 2 or maybe at the beginning of college algebra if that's the class you had. I looked this up. H, the Greek horizontal starts with, I think, a theta, which is effectively an H, or approximately an H. And the vertical Greek, it starts with a kappa, so that's why there's H and K's here. This is all Greek stuff, so they get to make the rules, they get to make the notation. Okay, so we don't have any adjustments, we don't have anything is off center, so we're just going to say 0, and 0 is our center. So we're going to go with that. That's not the foci, that's the center. That's different. Okay. And then the A is going to be, basically we have A squared. So A is going to just be 8 and B is going to be 7. They're not looking for the plus or the minus right now. They just want the distance. They just want the radius. Okay. Just the plus part will just work out just fine. If you put a negatives number in there, it'll be wrong, but you're talking about an inside-out ellipse. They don't. Right. So yeah, we got the green check mark. Okay. And again, if you have to look this up, on a quiz, I would probably phrase this more as to what is the major axis, what is the minor axis kind of a thing. Now, vertices specifically go to major axis. Okay, so if you have a vertice, what they mean by a vertice. These are the endpoints on the major axis. Okay, so even though we have the radius is going to be 8, it's 8 from the center. Okay, so we have -8, 0 for x's, and 8, 0 for the other way around. Okay, actually, let me double check to make sure. Am I doing this? I would rather have y. Y looks like the major axis to me. Okay, because that's bigger. Okay, so it's not a long an ellipse that's stretched out along the x-axis. It's an ellipse that's stretched out along the y-axis. So let me modify my answer here to be -8 in the y coordinate and 0, 8 again in the y coordinate. So those are the vertices of your major axis. Make sure they're in the right direction. But I think that's the hardest thing about that. So x, y, okay, and again 0, and again, if the center was different, then the x coordinate would be a different spot. So hooray, we got a green check mark. Okay, the endpoints of the minor axis. See, I like this. I like this wording because it's like, oh, the major axis, the big one, and the minor axis, oh, the small one. So it's really easy to kind of keep up with that notation. And in this case, the endpoints of the minor axis, those are along the x direction because there's going to be a long side and a short side for an ellipse. Otherwise, it's a circle. And that is going to be what's our minor axis? We said that's 64, so that's going to be 6, 0, and -6, 0. Okay, so we have 6, 0, and -6, 0. Okay, so there we are. -6. There we go. 0. Okay, so those are our minor axis. I like that. Oops, they don't like that at all. Didn't I like x, y? Oh, no. Okay. We got the right. Oh, that's why the square root of 49 would be 7. That's why. That's why they didn't like that. So let's change that to a 7. And let's change this to a 7. Okay. We're going to recheck that. Okay, there we go. See, now they're happy. Identify the foci. Foci. The formula for the foci for an ellipse, okay, is c squared is equal to a squared minus b squared. This is major minus minor, okay? And again, this is c squared equals major minus minor. So we have, what is this, 64 minus 49, I believe. Let's double check over here. Let's see, 64 minus 49. All right. Now, when I find my c squared here, okay, 64 minus 49. 64 minus 49. So that's going to be a 5. 5 minus 4 is 1. So c squared is equal to 15. So c is equal to the square root of 15. That doesn't really simplify down, but it's always relative to the center. So it's along the major axis, okay, relative to the center. Okay, but that's really the two hardest things about figuring out where your foci is. You have to realize it's along the major axis and it is relative to the center. In this case, the center is 0, 0, so that's not going to be too much of a problem. But you have to remember, oh, the major axis is in the y direction, so we're going to be 0, root 15 in the positive part, and 0, negative root 15 in the negative. Okay, so that's how we're going to do our foci. Okay, so we have 0, and then we have root 15, Okay, don't use decimals. They prefer like root 15. Okay, don't put decimals in there. Just give it to them as root 15, and that's what they're going to want. Okay, so check. So hooray! That's how we go ahead and get our foci. We'll talk about that in a minute for more of that. The length of the major axis. Well, how big is the major axis? We go from right -8 to +8. How much distance is between -8 and +8? So 8 minus -8. Okay, that's how we figure that out. So we'd say something like 8 minus 8. Oh, it's 16. There's 16 units long here. Okay, so that's how we're getting at 16 here. So 16. Check. Right. Great. Length of the minor axis. This one's going to be a little bit easier. It's going to be the same idea. Wait, 7 minus -7 because that's our foci, or that's our minor axis. 7 minus -7. Let's check. All right, hooray! And now we're going to graph the ellipse. So we're ready to plot some points. So place the center. Okay, that's at 0, 0. Place the vertex that was all the way out here at ±8, wasn't it? And then covertex. Okay, that's a nice name for the minor axis. Covertex would be the plus or minus points for the minor axis. Okay, so that sounds good. I like that name. Oh, you don't like that at all. Where did I mess up? We're at 0, 0. We are positive and -8. We are at 7 and oh, you know what I messed up? I got the orientation wrong again. So we got the center. And we're going to go all the way up to 8, and then our minor axis is going to be to 7. Okay, so we'll try. Let me check that one. Now we got our little green check mark, and we're ready to go on. Okay, so yeah, long problems to work on. Okay, so I'm sorry for that, but the more times they ask you, the better off you're going to get with being able to solve all of these things. So I urge you to be able to do that. So this has already probably been long enough. I'm going to go ahead and just cut it to say question 2 of 15. Oh my goodness, this is going to be a long chapter to do a lot of homework in. So please schedule yourself some time to do this. Okay. The more you do, the better off you're going to be. But they do go through a lot of this, and it's extremely tedious sometimes. So I'm sorry for that, but there we're going to go. All right. Good luck. Get some homework done. We'll see you in the next video.